Hello and welcome to this ArcGIS Survey123 presentation titled Advanced Smart Form Design. I'm Brett Stokes and today with me I have Phil Wilson and Jim Moore. In this presentation we will be covering a few of the ways you can use ArcGIS Survey123 Connect and the XLSForm specification to take your surveys to the next level. Firstly, I will take a look at some of the different ways to use your existing ArcGIS data to create dynamic choice lists in Survey123. I will then quickly demonstrate how you can use the image map appearance to provide a neat way to visually display choice lists using SVG images. Phil will be talking about a few ways of customizing your survey layouts to present them in a logical and intuitive way. This will cover using groups and pages in your survey, and then setting up a grid layout to make the best use of your screen real estate. Finally, Jim will cover JavaScript functions and how you can use them within your survey to perform powerful operations. When we refer to dynamic choice lists, we are talking about lists that can constantly change. This may be from the underlying data itself changing, for example, a list of staff members in a very large company. Or there may be another factor requiring the list to change. For example, if your location changes, the list of local school names will also change. A combination of these factors can also be handled in Survey123. I will be talking about two options for incorporating dynamic choice lists in your surveys. The first will be using linked content CSV to update choice lists outside of Survey123. And this eliminates the need to republish and assures that survey users always have the latest choice list. Secondly, we will create choice lists dynamically from existing data by querying CSV files or hosted ArcGIS layers using the search appearance in the XLSForm. Support for both of these options was added in the March 2021 release of Survey123 Connect and the Field app, and will be supported in the upcoming July 2021 release of the web app. Let's start with some background information on choice lists. They provide a survey with the list of choices that users can select from when completing multiple choice questions. They can vary in length from containing just one or two options to many thousands, hundreds of thousands, or even millions of options. Small static lists are best managed in the choices worksheet of the XLSForm. Large lists are best managed in the external choices worksheet or from an external CSV file. And this is because having a very large choice list in the choices worksheet is slower to load and uses more memory inside the application and form preview. Choice filters allow us to change the available options for a multiple choice question based on the response to a previous question. And we refer to this as a cascading select, and it really does provide the basis of a truly smart form. Here is the first option I mentioned, Link Content CSV, which allows you to populate a choice list using data in a hosted CSV item. It relies on linking an ArcGIS CSV item to your survey, which is what eliminates the need to republish your survey in order to pick up changes to your choice lists. This is done using the Linked Content tab in Survey123 Connect, and as mentioned, will be supported in the July 2021 release of the web app. The CSV file does not need to be copied to the survey's media folder, as this will happen automatically in the Field app the first time the survey is opened. You will need to click the download button in Connect to get the choice list into your survey preview. Linked content can be used with select one from file and select multiple from file questions in your XLSForm. And it can also be used with the normal select one and select multiple questions if you intend using it in conjunction with the search appearance. Let's take a closer look now with a demonstration. I've got a simple example here using a short list of names. As you can see here, I've referenced the name of the CSV item, it's called players.csv, in my select multiple from file question as per normal. But I haven't yet copied the CSV file into the survey's media folder or indeed linked the item. That's why you can't see any of the name options in the form preview. All I need to do is link the CSV item and download it to view it in Connect's form preview. And I can do that here in the Linked Content tab. Click the plus, choose CSV, and here is my CSV item. I click OK to link it. If I then download, we can see that in the media folder, the CSV file has been downloaded. And back in my form preview, I'll just update the form, you can see the names in the choice list. I've already published this survey, so I'll just go and open the Survey123 Field app, and again you can see the names in the choice list. If If I now get the source CSV file and add an additional name in here, I'll just quickly type one in. And save the file. I'll then go to my CSV item in ArcGIS Online, and I'll go to update this, grabbing the newer version that has the additional name in it, and update the online item with that source CSV file. Now that the CSV item in my ArcGIS organization has been updated, these changes will be picked up automatically by the Field app when the survey is next opened. And you can see the new entry there at the bottom of the list. It does this by comparing the timestamp of the CSV file on the device with that of the linked CSV item. And obviously you need to be online for this to occur. Okay, we can now move on to using the search appearance. The search appearance has a similar function to the linked content CSV. They both allow choice lists to change outside of Survey123. And these changes are picked up in your survey's forms without any further intervention by the survey author. That is, there's no need to republish. While linked content CSV is simply a mechanism to automatically download the latest version of a CSV item to your device for use in your choice list, the search appearance allows you to apply queries to your local CSVs and hosted ArcGIS layers, and these queries can be based on previous questions in your survey. At the top of this slide, you can see the full syntax for the search appearance. This expression is added to the appearance column for your select one or select multiple question. At a minimum, you can just use the table name parameter in your search expression. This will populate the choice list with all the records in your specified table. The next group of parameters, so search type, search column, and search text, are optional and are used to define the query expression, and I'll explain these further in a demo. The last group of parameters, filter column and filter text, are also optional and allow for an additional attribute filter to be applied to your query results. As mentioned, the search appearance can reference a CSV file on your device or a hosted ArcGIS table or feature layer. Linked content CSV can also be used to manage automatic updates of the local CSV file as explained earlier. The search appearance can be used alongside other appearances and, as is the case for all very large lists, should be used with the minimal or autocomplete appearance. Parameter values need to be enclosed in inverted commas, unless you are referencing a previous survey question where you can just use the $sign and the curly brackets. The usage of each parameter is best explained through a demonstration, but I'll just give a quick run through first. So table name. As mentioned, this is the only required parameter and the format is different for CSV files and ArcGIS layers. You can also apply buffers to the ArcGIS layer by appending additional distance and units parameters directly to the layer REST URL. Search type. I've listed the valid parameter values here for attribute and spatial queries. Search column. Values for this parameter are taken straight from the table you are querying. It defines which column to search. The additional values listed here, which is the @geopoint, @geotrace, and @geoshape, can be used for spatial queries, and they define the type of query geometry you are using. If I continue to run through these parameters, next we have the search text parameter, and that's the text value that will be searched for. Mostly, this is used to reference a previous survey question, including your geopoint, geotrace, and geoshape questions. We then come to the filter parameters, and these are only used if a query is already specified, and allow those query results to be filtered by attribute if need be. Filter column, which is similar to the search column parameter, values depend on the table itself and it defines which column to filter on. Filter text, this is a text value that will be used to filter the query results, mostly used to reference a previous survey question. Okay, so let's go through a demonstration to help explain the parameter values and see the search appearance in a variety of scenarios. Okay, I'm going to use a sample that I've been working on for this demonstration. It will be made available through Survey123 Connect. The sample just presents examples with hosted ArcGIS layers, but the same approach can be used with CSV files in the survey's media folder. All of the examples are used in conjunction with the autocomplete appearance. This just prevents the app from trying to render many thousands of choices on the form itself. To start with, we have an example that implements the search appearance in its most basic form. That is, we're just using the table name parameter. This allows us to populate a choice list using all 51 records from the USA states generalized layer. You can see from the search expression here that the unique name I've chosen for this layer is state. This is only used internally by Survey123 to reference the table. It doesn't have to match the actual table name of the hosted layer, but it must be different from all other table names and CSVs used in this particular survey. We then specify the REST URL, see that here, including the layer index. If I switch to the choices worksheet, you can see that my choice list named US states only needs to contain one entry, as we're going to query the layer to populate the list in full. We just need to include the names of the fields in the layer that we'd like to use as the name and label. In this example, we'll be using the field name state_name for both the name and the label. If I go over to the form preview, if I begin typing or hit the drop down, you can see 51 matches are displayed in the list, i.e. all the records as we're not using any query parameters. The second example uses an attribute query to populate the choice list from the USA counties feature layer. I'll just use this example to point out the impact of the max record count setting. This layer has 3,220 polygon features that each represent a county in the USA. The max record count setting is 2,000. If I go to the drop down and scroll the list all the way to the bottom, you'll see that I only get down to the counties beginning with M. Not all of the choices are in the list, only the first 2,000 as defined by the max record count setting. I'm using the following attribute query to overcome this limit. I've got matches as the search type, state name as the search column, and my previous question, which is the $state, as the search text. Now if I make a state selection of Hawaii, we can see that this list has been updated with only those counties from Hawaii. The last group in my sample survey includes some examples of different spatial queries, and I'll just demonstrate the behavior of a couple of these, and then we'll investigate one in more detail. This first example asks us to draw a polygon to be used as our query geometry, and then the list is populated with the names of the public schools that are contained by the search polygon. The next example is similar but uses a line as the query geometry and references a feature layer with line geometry. The search query populates the choice list with freeway route numbers that our query geometry crosses. The final example I'm going to show here incorporates all of the 6 search appearance parameters, as well as including a buffer to the REST URL of the hosted ArcGIS layer. The layer itself is already very dynamic. It's updated every 5 minutes and contains OpenStreetMap shops data for North America. Let's take a look at the syntax first and then see the behavior in the form. The table name parameter uses the unique name of store and then the REST URL for the layer that includes a buffer of half a mile. The search type parameter is intersects. The search column parameter is at geopoint. The search text parameter is referencing the geopoint question from the survey to use it as the query geometry. The filter column parameter refers to the shop field in the ArcGIS layer, which contains information about the store category. The filter text parameter references our previous question. If we take a look at how all this works in the survey form, we can initially see that our search point here in Austin, Texas, queries the ArcGIS layer and populates our choice list with 57 store names. If I go back up and select the alcohol category, we can see that our choice list was just updated then, and it's filtered to just the 2 choices. And if I choose a different category, say bicycle category, we can see that it is once again updated and filtered again to only 1 choice. Okay, hopefully that has got you thinking about some possible applications of the search appearance that will allow you to create dynamic choice lists appropriate to your workflows. I've put some links on this page to further information on dynamic choice lists, including the Survey123 documentation, Esri community blogs, and the sample available in Survey123 Connect. I'm now going to move on to a short section on the image map appearance. Today I'm just going to focus on configuring a suitable SVG file with a question that is already using the search and autocomplete appearances. First I'll give some background info, then outline the SVG file requirements and demonstrate the configuration process. When the image map appearance is applied to a select one or select multiple question, the question is displayed as an image instead of a list of text choices. The selectable areas in the image correspond to a value in the choice list. And even though the question is shown as an image, it is the choice list value that is stored, same as any other multiple choice question. Here are a few other examples of how the image map appearance can be used. As you can see, the images can vary in complexity and can also include rasters as background images, like in the lawn variety and the stranded oil distribution examples. All of these examples are included in the image map sample survey, which is available in the sample section when you create a new survey in Connect. The requirements for the SVG file to work with Survey123's image map appearance are as follows. There can only be one group per nest level, no empty groups, there must be at least one path element with an ID value matching a choice list value. The SVG must have a defined height and width, which is known as a viewport. And finally, the view box parameter is optional, but if it is included, it must match the dimensions of the viewport. All of the requirements and recommendations are listed in the image map appearance documentation and also in an Esri community blog I wrote called Using the Image Map Appearance in Survey123. Links for both are at the end of this topic. The image map appearance must be configured in your XLSForm. It is not supported in the web designer or the web app. Here are 5 steps that will allow you to configure the image map appearance in your survey. I'm going to follow these steps in my demonstration. Okay, I'll be applying these steps to the sample I was using in the previous topic. Step 1 is already covered, as I know my US states choice list is working as expected, populated by all records from the hosted ArcGIS layer using the search appearance. I'll open my SVG in a text editor and compare my path element IDs with the values in my choice list. I can now remove the autocomplete appearance and add in the image map appearance. For step 3, I need to add the SVG file name, including the file extension, to the media image column. And for step 4, I need to copy the SVG file into the survey's media folder, which I've already done. Step 5 is just to save the XLSForm and update in Connect to see the changes. As I click the different states in the image, you can see that the selection changes and the corresponding attribute query is updated for the USA counties question below. Here are some references for more information on the image map appearance. There is documentation, a blog, and also a brilliant story map by Rachel Abernathy from Esri Ireland that goes into the detail of converting your spatial data directly into SVG files from ArcGIS Pro, and then using them in Survey123 Connect. Okay, that concludes the first 2 topics of the presentation. Now I'll hand over to Phil for the next 2 topics, which is groups and pages, and then grid layouts.
Thanks, Brett. Now let's take a look at how using groups and pages can help organize and improve the navigation of Survey123 forms. Groups and pages are 2 methods for enhancing the layout and design of your forms, especially with long forms, as they can help improve the form navigation. They provide better use of space, can assist users who are completing questions out of sequence, and also make the form look neater. You can add as many groups to a form as you like, and a group can contain other groups as well. We call these nested groups. You can also apply colors to make your survey more accessible and easier to follow. Groups are supported in both the Field app and the Web app, and you can add them to your surveys when authoring in both Connect and the Web Designer. The syntax to use in XLSForm is begin group and end group, and these can be selected as question types in the type column. Groups support the use of the compact appearance to collapse the group by default, and by using expressions in the relevant column, you can hide and show groups depending on whether they are relevant to the user based on their previous answers, in the same way you can with individual questions. You can also hide a group using the hidden appearance or the body Esri visible column. The key difference between hiding and relevant is that with hiding, all questions still function as if they were included on the form. Defaults and calculations will be submitted with hidden questions, whereas if a group and its questions are not relevant, no data is submitted. Here are 3 appearances you can use with groups. As mentioned previously, you can use the compact appearance to collapse the group by default. The field list appearance is used to create pages in your survey, and table list is used for creating a single choice grid question. We will go through these in more detail shortly. You can apply background and border colors to groups in the body Esri style column. These can be provided as a HTML color name or hex code, or you can even use a question variable to determine the color. Note that grid layout or table list groups do not support border color. Pages are very useful for separating a survey into logical sections and are very useful when the survey has a lot of questions. Pages can help to indicate the progress of a user through a survey. The page number and index can also make it easy to navigate between pages or sections of the survey. You can also use relevant expressions on pages and the hidden appearance or body Esri visible column to hide pages from the form. Similar to groups, pages are supported in both the Field app and the Web app, and you can add them to your surveys when authoring in both Connect and the Web Designer. To design a survey that uses pages, first set the style to pages on the settings worksheet. Then apply the field list appearance to each group that you wish to be shown as a separate page. You can include groups within a page. Groups do not become pages unless you set their appearance to field list. When working with pages, it is good practice to have all questions in your survey within a page. If you leave questions outside of a page, you might experience strange behavior across the Field app and the Web app, where a single question may appear on every page. Here is an example of an XLSForm using groups, with background colors to separate different sections in the survey, and also using the compact appearance. And when we take a look in the Field app, this is how these groups appear. As you can see, by using compact, we can see each group starts already collapsed, and we're able to expand and collapse them and also see the different colors of each group. Here is an example of using pages in XLSForm. The style in the settings sheet has been set to pages, and each begin group in the survey sheet has the appearance set to field list. This will create a new page for each of the groups where field list has been set. The questions inside the groups will now be split onto different pages, which are displayed with a navigation bar at the bottom of the app showing the current page and total page count, and buttons to navigate back and forth between the pages. You can also select the page number to display an index of the pages and select the page you want to jump to directly. This is helpful if you have a lot of pages that do not need to be answered in a particular page order. If you are authoring a survey in the Web Designer, you can easily add groups by dragging a group onto the form and then dragging questions into it. Note that you cannot nest groups in the Web Designer. However, a survey with nested groups published from Connect is supported in the Web app. Here is an example of how to use the Web Designer to drag and drop groups into the survey preview. Once the group is added to the preview, we can add questions into it by simply dragging and dropping each question inside the group. Once all the questions are added, we can then give the group a label to make it more meaningful to the user. We can also set the group to be collapsed when the form first opens. This works the same way as in Connect and the Field app. And now, here is an example of how to use the Web Designer to drag and drop pages into the survey preview. This works much the same as adding groups. Once all the questions are added into the page, we can also give the page a meaningful label so that the user can see the title of that page. With the Survey123 web app, here you can see the groups expanding and collapsing to reveal the groups of questions inside each group. This is very similar to how it works in the Field app. And as you can see in this case, all of the groups started as collapsed because the compact appearance was used. And here is how pages look in the Survey123 web app. Once again, similar to the Field app, there are buttons at the bottom to navigate back and forth between the pages. There is also an indication of the current page you are on and the total number of pages, and a green slider to indicate the overall progress through the survey. Another thing you can do with groups is present a group of select one questions in a grid or table layout. In XLSForm, this is called the table list appearance. In the Web Designer, it's called a single choice grid. All questions in the group must be using the same choice list. This is great for a long list of questions that have a small number of choices. It saves a lot of space and makes the questions look like a checklist that users can quickly complete. There are a few limitations with table list. Most notably is that table list is for select one questions only. It does not support select multiple questions. Here is an example of how to use the single choice grid question in the web designer. You can configure the choices and columns to have as few or as many choices as needed, and then configure the questions, which are the rows, to also have as many questions as you need. On the right, you can see how the single choice grid will appear when viewed in the web app. Now let's take a look at how to create grid layouts in your survey forms using Survey123 Connect. Grid layouts can help you organize and improve the layout of questions in your survey. By default, Survey123 presents your questions, groups, and repeats one after the other in sequence. A grid layout helps you make good use of screen real estate by positioning questions side by side. Often, a survey author would like to reproduce an existing paper form that uses a grid layout, such as a form from the tax office or when you visit the doctor. Grid layouts can make your survey easier to follow and quicker to complete by arranging the questions logically. Grid layouts are generally more suitable for larger screens and tablets in landscape. If your survey respondents will be using a mixture of devices, you could consider having two versions of the same survey. One that's designed with smartphones in mind, using a traditional layout, and another one that uses grid layout for your users who will be working on a tablet. One of the key things to note is that the grid layouts are not supported in the Survey123 web app or web designer. A survey with grid layout can only be authored and published from Connect and can only be used in the Survey123 field app. There are a few steps to set up a grid layout. On the settings worksheet, set the style to theme grid. Divide questions into groups. The survey must have at least one group. Set the total width, the number of columns for each group. This is the W appearance. Configure widths for each question, also using the W appearance. And we'll go into this in more detail shortly with an example. The layout of each group and the questions within that group are determined by the W appearance. First, set the group's total width. This is measured in equal width columns relative to the width of the group, which again is determined by the device's screen size. So a group with a total width of W8 will span 8 columns or cells of equal width. If you have other appearances for a question, these can be entered in the appearance column along with the W tag. Just ensure they are separated by a space. Here is an illustration that attempts to demonstrate how the widths work in XLSForm. You can see that the total width for the group is set on the Begin Group row in the appearance column, shown here in yellow at the top. The widths from individual questions inside the group are set to determine the position of each question in the grid, shown here in red, purple, and green. Once the question widths add up to the total width, the next question will be placed on the next row of the grid. The example on the right is what the vehicle description group from the XLSForm will look like when using the field app. To display repeats in a grid layout, each repeat must contain its own group that has widths applied to it, so that those questions inside the group, inside the repeat, display as a grid. The W width appearance cannot be applied directly to the begin repeat, hence why a group must be used inside the repeat. Here is an example of a survey designed in a grid layout. You can see the questions are arranged side by side, making great use of the landscape tablet screen. Questions are positioned in a logical manner. And here is another example using two repeats, one for water sampling and one for soil sampling. These are displayed side by side with their own grid layouts inside each repeat. Well, that's all you need to know about groups, pages, and grid layouts. So now I'll hand over to Jim to tell you all about JavaScript functions.
Thanks, Phil. Hi, my name is Jim Moore. I'm a product engineer on the Survey123 team. And in this section, we'll talk about how to use JavaScript functions in your Survey123 smart forms. In this presentation, I'll provide an overview of how JavaScript functions work with XLSForm. There's a lot you can do with JavaScript in your Survey123 smart forms, and we'll explore some examples. Then I'll demonstrate how to use JavaScript to query a feature layer to retrieve the geometry of a polygon and then store it in a geoshaped question. I'll also cover the limitations and share some resources where you can learn more. JavaScript functions give you the flexibility to implement advanced techniques and logic in your smart forms that goes beyond what's possible in XLSForm alone. Using the pull data function in XLSForm, you can invoke custom JavaScript functions to build complex calculations, work with external data sources, and so on. JavaScript functions are supported in both the Survey123 Field app and the web app. While JavaScript gives you a lot of flexibility and functionality, there are some limitations, so it's good to use standard XLSForm features and functions where you can. The Scripts tab in Survey123 Connect helps you manage your JS files and also test your functions. JS files must be stored in the Scripts folder for your survey. And pull data at JavaScript is often used in conjunction with pull data at JSON for extracting individual elements from a JSON response. To work with the JS file, the pull data function requires, in this order, the @JavaScript, which tells the pull data that you want to execute a JS function, the name of the JS file with extension in quotes, the name of the function in that file that you wish to run, and as many parameters as the function takes. The parameters can be derived from questions in your survey or as static value in quotes, for example, a text string. There are countless use cases for JavaScript functions, but here are a handful of the common uses in Survey123. You can use JavaScript to work with your ArcGIS data. For example, you may want to bring attributes from an ArcGIS feature layer into your survey. You might also want to perform spatial analysis using hosted feature layers. For example, to find which polygon a geopoint falls inside, or to check if a survey record has already been submitted, or obtain geometry based on an attribute. JavaScript functions can be used for working with repeats. You can use JavaScript to communicate with third-party web services. JavaScript can also be used for complex calculations, such as statistics. Let's take a look at some examples. The JavaScript sample XLSForm is an excellent resource to help you get started. It's available from the list of samples in the new survey dialog in Survey123 Connect. The sample contains several examples that cover many of the common use cases. Let's take a brief look at some of these. In this example, the JavaScript function takes the geopoint location and queries a hosted feature layer of administrative areas to get the point in polygon intersection. The location here is Palm Springs Airport. The code and name attributes for the corresponding administrative area are returned from the feature layer. This is also a neat example of pull data at JSON, which is used to extract the individual element from the JSON response and write it to a text question. Here's an example of working with a third-party web service, in this case the Open Weather API. Here we've got the location set to sunny Santa Monica Pier. Accessing live data like this is really useful for recording conditions or status at the time the survey was taken. In this example, the pull data at geopoint function is employed in the XLSForm to extract the X and Y coordinates from the geopoint question so that these can be sent with the API call. Pull data at JSON is used to parse the JSON response, extracting the location, conditions, and current temperature. There are two methods for working with repeats. The first is to pass a question from a repeat into your pull data expression, which will pass in the values for that question as an array. With this method, it's important to keep the pull data at JavaScript outside of the repeat. In the first example shown here, the values from the observation question in the observations repeat are passed to the function to calculate the standard deviation. The second method is to pass in the entire repeat as an array, which will itself contain separate arrays for each record. In this second example, the JavaScript function receives the whole repeat, then filters the values based on category before calculating the standard deviation. And finally, JavaScript can be used to pass complex data structures like the one shown here. This is from a driver's license barcode, and it encodes information such as name, date of birth, and so on. Say you had a Survey123 form with a barcode question that scans this type of barcode. You could then use a script to decode this data. See the Esri community blog post on custom JS functions for more details, including an example script. I'll now demonstrate how to add a JS file to a survey and work with a JavaScript function in the XLSForm. Here we are in Survey123 Connect. In this survey, the user can select a parcel number from a Select One question. We're now going to add a JavaScript function to take that parcel number and retrieve the geometry for that land parcel from a hosted feature layer. Each parcel in this feature layer is identified by an assessor parcel number, or APN. Here's the feature layer in a web map. These parcels are in the city of Redlands. You can see the Esri campus in Redlands here. And you can also see the APN attribute for each one of these parcels. We'll use this APN to make a query request using the ArcGIS REST API. And the polygon geometry will then be used to populate this geoshape question. On the Scripts tab, you can manage the JavaScript files for your survey and test your JS functions. This survey doesn't have any scripts yet, so I'll click New Script to create a new JavaScript file. I'll name this file parcel lookup.js and click Create. The file opens in the Scripts tab with some sample syntax to help you get started. Script files must be stored in the Scripts folder for your survey, and clicking the Folder button will take me to the Scripts folder. Note that while the Scripts tab provides some useful tools to assist you when authoring surveys that contain JavaScript functions, it is not designed to be a fully featured IDE. You can easily open a JS file in your system's default IDE by clicking the Launch External Editor button from the toolbar and work on your script file there. Here's a function I prepared earlier, shown here in an external editor. The function is called location by feature, and it accepts the APN as a parameter. Here we define our layer URL, which is the REST endpoint of the feature service that we'd like to retrieve the geometry from. Next, we set up our query parameters. These include setting the response format to JSON, and we want the response to return the geometry of the feature. We also want to find the feature where the APN attribute matches the APN value from our survey form. The query parameters are appended to the layer URL to create a request URL. We then create the request object and send the request. Then we process the result. If the request is a success, we extract the array of coordinates from the JSON response. For each element in the array, we reformat the coordinate pairs and separate each with a semicolon so that the coordinates are in the correct format for the geoshape question. I'll now copy and paste my script into my new parcel lookup.js file. There it is there, and click Save. Okay, let's test the function. The Select Function button will automatically highlight the first function in your JS file. With the function selected, you'll see a few new tools in the pane below. You can see that it's prompted me to enter the APN parameter. I'll enter a test parcel number and click Run. Here you can see the result, and the response data type is string. The cool thing here is that on this line, the pull data syntax for my function has been put together for me. And I can copy this to the clipboard by clicking this little button here and paste it directly into my XLSForm. So I'll paste it into the calculation column for my text question. The only change to make here is to ensure the parameter name matches my select one question name, in this case, APN. And here you can see the pull data function contains the @JavaScript, the JS file name, the function to run from the JS file, and the APN as a parameter. I'll set the field length for this question to 10,000 in the bind Esri field length column. This will override the default of 255 characters, which will ensure the field is large enough to hold the JSON response. we want the result of the query to be written to the geoshaped question. So I'll add that here in the calculation column. Lastly, I'll add the following to the pull data function so that the geoshaped question treats the response as a string and to ensure Connect doesn't throw an error. Just for demonstration purposes, I'll also set a default APN. This parcel is located at the Esri campus. And now I'll save my XLSForm. Back in the form preview, here is the result for this APN with our nicely formatted coordinate pairs, which are then drawn as a polygon in the geoshaped question. Back in the XLSForm, I'll hide the geometry query question so that users won't see it on the form using the hidden appearance. I also don't want to store the JSON response in my feature layer, so I'll set the bind Esri field type for this question to null. Back in the form preview, you can see the geometry query text question is now hidden from the form. And now I'll click Publish. Now let's check it out in the Survey123 web app. On load, you can see the default parcel for Esri Campus is drawn in the geoshaped question. And I'll run the function again with another parcel. I'll just select something at random. Take this out. Let's just pick one here. And you can see the geoshaped question is updated with the new parcel. JavaScript functions are not supported in surveys that are shared publicly, and JS functions will only work for users signed in to the same organization as the survey's author. Local files cannot be accessed by your scripts, and asynchronous calls are not supported. When a JavaScript function is executed, Survey123 waits until something is returned. This could be a performance consideration when employing complex JavaScript functions. The document object model and some frameworks are not supported. To learn more, head over to our Esri community blog for a detailed post on using JavaScript functions in Survey123. You can also find more information in our documentation. And the XLSForm sample in Connect is an excellent resource for getting started. That concludes this section on JavaScript functions and our ArcGIS Survey123 presentation on advanced smart form design. On behalf of Brett Stokes, Philip Wilson, and the whole Survey123 team, thanks a lot for watching. We encourage you to ask questions and engage with our active Survey123 community on the Survey123 Esri community, and also to join us on our early adopter site, where you can test out new features and provide feedback prior to release. Speaking of feedback, we'd love to hear your feedback on this session. Please let us know how we can improve by completing the session survey at the link below. Once again, thanks very much for watching this presentation, and we'll now transition to our live Q&A session.